We're looking at page 8 of our notes. So do these kind of look like what we worked on last week when you were, or on Friday, you were graphing those parent functions? Do you agree any, I didn't have you graph a horizontal line of y equals 0. But you guys, this looks like y equals x. You down with the parabola? You down with little x cubed? We down with the square root? Beck, you down with this? Absolute value? Guys, we don't have to worry about this greatest integer function. I'm not going to ask you about that, okay? And then 1 over x. Here's what we got to be familiar with. Bob, we got to be familiar with these general shapes. So when I say absolute value of x, whoosh, we're going to do this. Actually, yeah, we'll get to math aerobics. Now let's do it. So when we graph this, that shifted my square root graph up 2. Was this plus 2 under my square root? It's not. So that's really important to note. So you guys, what I want us to do, it says use the parent function to sketch the graph. So you guys agree the square root of x starts at the origin. All I want us to do is go take each of those points and let's shift them up 2. So we're going to say, oh, I started here, but now I'm just going to go up 2. So let's put our new origin right there. And I want you to picture this is my new origin. Let's just act like this is my new xy, and you don't have to draw that in there. But if that was my new origin, what if I went 1 to the right? What's the square root of 1? 1. So that's going to get me that point right above it. I'm acting like this is my new origin 0, 0. Do I know what the square root of 2 is? No, but do I know the square root of 3? No, do I know the square root of 4? So if I go 4 to the right, I'm going to go 2 up from that new origin. Boom. And then I can, boop, say that's what my new graph looks like. Let's go see how this changes it. Any predictions?
It's going to go to the right.
It's so annoying, you guys. Let's go graph this. Keep the original one of square root of x. Then on your second one, I'm going to do x minus 4. And look at that. My red graph is x minus 4. Which way did it take my red graph? It took it to the right. Anyone a little annoyed at that? No, I'll show you why. So if I were you, I would go ahead and say that this is going right 4. That is confusing to me. We're going to graph it, and actually this is the reason why. The reason why it goes the opposite direction than what we might think is you're always looking for the 0, Ben. So you guys don't have to write this if you don't want, but you always just set what's under that root equal to 0. Add 4 to both sides, and I'd get my x is positive 4. That's why we're going right 4. So it's always just the opposite. So you guys, my square root graph, do you agree? Square root always started at the origin. And now this is just saying, oh, take that origin 4 to the right. So I'm going to go like this. 1, 2, 3, 4. That's my new origin. I don't know why it copied so weird and left some blanks there for you. Sorry about that. You guys, if that's my new origin, let's act like that's the new 0, 0. What's the square root of 1 if I went 1 to the right? 1. So I can say, all right, that's still there. I don't know the square root of 2, the square root of 3, but I know the square root of 4 is 2. So I can go throw that in and then whoop, draw my nice little curve. What happens when we put them together? What's that plus 3 going to do? Yeah, this plus 3 under the root, that's going to take it left 3. And then Bob said that minus 1, because it's out of the root, that's going to take it down 1. So good, Bob. So, again, we take that general shape, and we're going to go left 3. So I typically start at the origin. I'm going to go left 3, and then I'm going to go down 1. This is my new origin. Boom. We okay with that? Okay. If that's my new origin, boom, boom. Square root of 1? 1. I don't know what the square root of 2, 3 are, but I know that the square root of 4 is 2, and I could go up 2 there. And then I'm just going to draw my nice curve. Okay, let's predict this one. You guys, the parent function of this graph, what parent function do you think I'm dealing with here? What's the original? Good old x squared, okay? What are we doing to that x squared? This is now in the parentheses, so we're going to go to the right 2. So if I were you, I'd write myself a little note. We're going right 2. What are we doing here? Down 3. That's going to be down 3. You guys, did they do that on my parabola? Did they take my origin, Beck, stay with me for 1 sec. Did they take my origin of x squared? Did they go to the right 2? Down 3. And just shift it down? Okay, now, what does absolute value mean? Make everything positive. So they're just saying make everything from this graph positive. Question, are these values of this graph already positive? The y values. Yeah, anything above the x-axis is positive. Are these y values positive? So what are these y values? Negative. So I'd have to make them positive. How would I make this? What would this point become? What would this point become if I had to make it all positive? 2, 3. You guys, if I did that, that new point is right here. So just like Ritzy's saying, he's like, oh, if I needed to make that positive, it's going to reflect over that x-axis. So you guys, I'm good with us leaving, and it doesn't have to be perfect. I'm good with us leaving that original part there. Then we had to reflect it over the x-axis. Boom. This is what the absolute value of that graph would look like. You guys, we're on page 9. Check this out. So if we've got a cube root of x graph, what did they do? If this was my origin, what did they do to my origin? They moved it up 1. How would I write that? Cube root of x would have what done to it if I'm trying to move it up 1? Plus 1 under the root, not under the root? Not under it. It's just going to be boom, plus 1. Yeah? Anytime we're moving things up and down, it's not going to be in the parentheses or under the root. When we're moving things left and right, let's actually look at this one first. Let's do C first. Look at this new origin. They moved it to which direction and up? This is where we started. We went to the left and up. Okay, how would I move something to the left? Okay, I like it. So you're saying cube root of x plus how many? 2 has to be underneath that root. And then I heard it. Vise, what'd you say? And he said plus 1. And how he said it, I knew he meant not under the square root. That's how we're going up. You guys, how do you think we're going from here to here? You saw it. Yeah, how? What's the opposite in terms of math? Negative. How do you think I'm doing this guy? Negative cube root of x.
And then is it still just minus 1?
Ooh, in the square root or not?
Not in the square.
Right. So if I've got to go left or right, it's always in the square root. If I'm going right, it's the opposite of what we'd want to do. So if I'm going right, we're going to say what? Plus 1 or minus 1 under there? Yeah. Boom. My little negative sign could be a little confusing. VC, you know what I'm excited for you for? Sleep. Here we go, you guys. Here we go, you guys. It says, describe how these graphs are related. You guys, if F was the blue graph and G is this pink graph, all I want you to tell me is in words what happened here. We just took this and we went left how many? Done. All you got to do if I were you is I would just say left 4. Boom. Because it's very minimal. You guys, what did this negative sign do? Whoosh. Whoosh. Flipped it over the, which axis? Well, we're going to go X every time. So I want you guys to draw yourself an arrow. And this is how you're going to do this on a test too. You're going to say that thing right there, reflected over x-axis. We're going to do lots of arrows. What did this 3 do to my x cubed? Here's x cubed. Here's 3x cubed. What would you say? Again, it doesn't need to be a fancy word. Made it skinny. That's what I say. Made it skinnier. So you can just write skinnier, thinner, whatever you want. Whatever works for you works for me of letting me know it got narrower. Okay? I'm fine with that. Okay, so then Mr. Coop was just saying, okay, how are you expecting us now? So on 8, you guys, these 3 questions refer to this graph. This is my parent function. You guys, it looks a little bit like this. Ready? Boop! Anyone have a prediction what that 0.2 is going to do to it? Wider. Nice. It's going to make it wider. Now, if it took your calculator to help you see that, that's fine, you guys. But this is going to make it wider. I'm going to just prove it to you all real fast just because we only did that with math aerobics. If I went And I said, what is x squared versus 0.2x squared. Do you agree my red graph is wider? Okay. What is this minus 5 and my minus 2 going to do? This minus 5 is going to go right 5. And then it's going to go down 2. That's all I'm looking for. I don't need novels. But everything other than the parent function needs a statement. Meaning my parent function is x squared. What's my 3 doing to that x squared? So again, let me just go show you. There's x squared. Let me show you a 3x squared. X squared is blue. 3x squared is red. What did it do? Made it skinnier. Made it skinnier. What's that plus 6 going to do to that graph? It's going to shift it all the way up 6. That's all I'm looking for there. So again, the absolute value is going to make all my values positive. All my y coordinates are going to be positive. This one we've got to write 2 different things on. Again, if this is x cubed, what's that negative going to do? Reflect it over the x. Thanks for saying that. A lot of people want to say flip, and that's not enough words for me. I need reflect over the x-axis. What do you think the 2 is going to do of an x cubed graph? It's just going to make it skinnier. What if it was a 0.2? Wider. Very good, you guys. What about a 0.75?
Wider.
Yeah, because it's less than 1. So this 0.75 is going to make it wider. What about plus 1 that's in my parentheses? Nice, you guys. That's it.